That I wish to welcome everybody. We starting now this session. So I want to introduce our speakers that are all part of our ground operation, automation and digitalization working group. My name is Massimo Ciccetti. I am the moderator of this session. I am working in IATA as head of innovation and efficiency ground operation. And I wish to introduce you Tom Franco, which senior manager, technical expert, aircraft engineer or DCS implementation at Amadeus. Todd Schulze, weight engineering configuration control at Boeing. Karel Tavernier, technical director of Reconcentra. And Trevor Tweed, we have lost his name during the revision of the slides, flight operation engineer, training and flight ops support department at Airbus. So we go to the next slide. So let's start with the basics, why we have put together all this work that we have done in the last 4 or 5 years. In essence, the main reason is increase and improve flight safety. Now, in 2018, FAA has published this safety bulletin 18012, where they have investigated a number of incidents that happened due to wrong configuration of the DCS system as data were not properly configured and communicated by the airline to the DCS provider. And as an action, they are recommending to do all possible to mitigate this risk. So with that, we have developed a much better way to handle aircraft semi-permanent data directly from the source to the end users. And I wish to hand over now to Tom Franco to start the presentation with all our speakers. Over to you, Tom, please.
Okay, actually, we'll pass it on to Todd at Boeing to give us some background and insight into the kind of data that we're going to be talking about today in terms of weight and balance and load control systems. So over to you, Todd. Thank you.
Thanks, Tom. Hello and good morning or good afternoon, depending on where you're located. My name is Todd Schulze. I work in weight engineering at the Boeing Company. I'm here to briefly talk about the weight and balance manuals, what they are, a summary of the data contained in them, and why it's important. The weight and balance manual is a certified document that defines the weight and balance limitations of a particular aircraft type and unique operator configurations within that type. It's the primary source of data for developing load control systems. It defines the structural limitations of the aircraft, the maximum weights, the taxi weight, the takeoff weight, zero fuel, and landing weight, the cargo and compartment and main deck running load capabilities. It defines the maximum combined or cumulative loads or limitations of an aircraft. These limitations ensure that safe operation within the design capability of the aircraft. Weight and balance manuals provide the details of the cargo hold layouts, whether it's a bulk loaded airplane or a ULD capable. If it can transport those ULDs, their weight capabilities and viable loading configurations through locks and stops and bay groupings are specified. Rules and procedures for dealing with missing and operative locks are included as well. They define the center of gravity envelopes per the aircraft configuration and the operating weights that are specified by the airline. Flights must always be loaded within that certified envelope, even after accounting for known estimation errors and potential CG movements in flight. The layout of the fuel systems, including tank volumes and balance arms from empty to full, and the fuel loading and usage sequences are all specified in the weight and balance manual. Cabin layouts are provided, detailing the passenger and crew locations, as well as the galley capabilities for the contents and the gross weights of what the galleys can hold. Weight and balance manuals have a bunch of other data covering the balance reference system and the ground handling limits, trim information, and other critical data required for the safe operation of an aircraft from a weight and balance perspective. And as I've mentioned before, all this data is key to developing a load control system. The weight and balance manual is the certified authority for the weight and balance data. The X565 infrastructure that's been developed here provides a uniform way and structured way to transfer that data to various interested parties. So I'd like to give Trevor an opportunity here to comment on weight and balance manual as well.
Okay, there. Thank you very much, Todd. So Maybe in terms of format, maybe a few little presentation differences between a Boeing weight and balance manual and that with an Airbus one, but the content really is largely the same. Everything that Todd has spoken about there, all of these sections of the weight and balance manual, these are also covered in the Airbus manual. I would say the Airbus weight and balance manual, it's not written as an operational document. You wouldn't open it up in flight and consult it. It's more of an encyclopedia. It is, as Todd said, it's the source data. It's a very dense document. It contains an awful lot of data in it. But I think the key point is really that whether you're starting from an Airbus or a Boeing weight and balance manual, the content is largely the same. So it's a very good common starting point for everything which Tom is going to talk about. Tom and Carol will talk about over the next few minutes. So over to you then, Tom.
Thanks, Trevor. Thanks, Todd, for that kind of setting the concept of what we're going to be talking about today. I guess if we go back now to the history of this initiative or this data transformation that we've been working on, to kind of show you what our original concept was and why we want to do this, and you know, what we've done in the last 5 years to get to where we are today, you will see our kind of evolution of this thing to make it a real live concept now rather than just an idea. So we started about 5 or 6 years ago at the IATA Ground Handling Conference in Bangkok, where we did this presentation on the current process for delivering data from manufacturers and airlines into departure control systems. We looked at the manual effort required and the time required to do this process, and we had an objective to find a more efficient way of getting data from one place to another, quickly, accurately, and most importantly, of course, very safely. And we'll talk more about that a little later on in this presentation. So this slide here, we can see from a few years ago on the at the conference in Bangkok, and that the slide in question gives us that very convoluted process of receiving data from an aircraft manufacturer, passing it to weight and balance engineers in an airline, who then reformat that information into a set of data sheets that we're probably more familiar with in the context of the AHM 560 and AHM 565 format. And then that data is then passed on to a DCS specialist who will input the content of that data report into a database to make it ready for the departure control system to process flights from a load control point of view. So that process, it's an expensive and quite slow, convoluted process. And our intention is to wipe away all of this old way of working and simply take an electronic data file from one place, pass it over to another, and import it directly into the database with very little effort, very little time required to actually do that. So that's really the background to the X565 and what we want to talk about today. The big objective here is two things. One is efficiency. So from a business point of view, we can save a lot of time and money. And the second one is flight safety. So flight safety, of course, is the number one priority. And we believe that by taking out a very slow, labor-intensive process that has many entry points for human error, then we have the ability to really improve or remove the risks of data errors that could cause a flight safety incident. So this has been as I said, a 5 or 6 year process. We started in 2017 with the project conception and the ideas. We've been working with people in many different organizations. So as we can see here, we have aircraft manufacturers, we have airline representation, and we have DCS providers all working together for a kind of common objective here. So based in many different parts of the world with different ideas and yeah, different operating environments that allow us to consider everything. So we did a lot of analysis over several years to look at exactly what this should be. Then once we had a basic idea, we put together, or we designed an XML file. So XML is, for those of you that are not kind of computer minded, it's just a way of formatting data or wrapping up data in an electronic file in a very structured kind of a way, so that a machine that receives this data file can read it and interpret it safely and accurately and use it accordingly. So it's the format that we decided to go with, and this structure then becomes an IATA standard that we can use in all different areas of the industry, whether it's an airline, manufacturer, DCS provider, and so on. So once we had designed the basic structure of that data file, we then went into quite an extensive testing and evaluation process that also involved remodeling a little and just adjusting to ensure that the data file has the ability to accommodate any data from any aircraft manufacturer. And as Trevor mentioned just now, the data, whether it's Airbus, Boeing, Embraer, or any of the other manufacturers, is essentially the same kind of thing that's published in slightly different formats, but it kind of amounts to the same thing. So the structure of the data file that we have invented, if you like, is designed in such a way that we can accommodate anything from any manufacturer. So then once we'd got past the design and development of it, we went into a phase of writing documentation and planning this process of rolling out the concept to the industry. So we have created several documents that we'll talk about a little later on before we wrap up this session, that involves implementation guides and user guides to assist anybody that wishes to use this data file concept in live operations. So 2022 was our rollout year. So last year, the data file became an IATA standard and a recommended practice. And now we're ready to go in the industry. And we have a lot of interest in the industry now to use this file. And I think this year will be the year that we really see it begin to take off. Okay, so just the looking at the process in today's world and compare this with what we can do with the data file in the future, so that you can see the real benefit of going this way. Starting off with the old way of doing things, so a manufacturer would send perhaps a PDF document to the airline operating the aircraft, and the airline's weights engineers or weights engineering external contractors would turn that data into a set of data sheets that we talked about before, so the AHM 560, 565 type data. So there's quite a lot of effort there on the weights engineering side of things to create the data from the manufacturer into a kind of industry recognized standard format of perhaps AHM 560, 565. And that data is then passed to DCS specialists who use the data report to physically configure the departure control systems. And that in itself also can be a very extensive, time-consuming process. So here, these numbers are very arbitrary, 20 days plus 5 days. That could easily be 2 or 3 months of effort, depending on the complexity and the automation being used in the departure control system by that particular airline. So just as a guide, really the message here is that it's an extensive activity that requires a lot of effort. So with an electronic data file, the idea is that we can take that in a standardized format and just feed it into any departure control system. And within a matter of minutes, that data can be available in the system for operational use. So we have proved this concept at the IATA ground handling conference last year in Paris. We did a demonstration of this where we took a data file and we configured a very complex departure control system, and we created a flight that we could process within this 3-minute window. So it's very real. As a demonstration, 3 minutes is kind of realistic, but of course we know that there are other things that have to be considered, such as the validation of the data and so on. But the physical transportation of the data from its source and into the DCS database, we can see now is a very kind of quick and easy process. So the structure of the file, just to give you a little insight into what the file really looks like and how we can store data in it. The file allows us to store carrier level data. So that would be information such as standard passenger weights and standard bag weights and so on. So all the high level non-aircraft type data. We have an area where we can specify all of the individual aircraft. So, for example, I may have a fleet with 3 aircraft types in it. In this case, a 777, A330, and Embraer 190. And so I can make a group where I can specify all of the technical data for each of those individual aircraft. So if I take the grouping of A330, for example, first thing I can do is specify a master list of all of the aircraft tail numbers or registrations that are defined within that A330 grouping. And I specify the high-level weight and balance data that exists for that particular aircraft. And then I can kind of drill down to the more specific data. So this is where I would add center of gravity envelopes, fuel tanks, cargo holds, and so on, and specify all of the very individual explicit weight and balance data. I can put multiple definitions in this area. So as we all know that a fleet of aircraft is not always identical, and 1 or 2 tail numbers may have their own specific technical specifications. So we can kind of build exceptions tables. So, for example, we may have some aircraft with a different center of gravity envelope and perhaps different maximum operating weights. So we can pull that out of the sort of main configuration, create a secondary configuration there with center of gravity limits and maximum weights in it, and then define which of the registrations are applicable to that particular set of data. Then for any other registrations, we would have a separate grouping of data again, where we can specify that individual aircraft. So the point really here is that we've structured the data file template, if you like, for any kind of variations of data that might exist. And we very much follow the structure of the aircraft manufacturers in the way that they specify their data with kind of exceptions and so on. And I'm going to pass over now to Carol, who's going to talk about implementation and the more technical aspect of XML from a developer point of view. So for some of us that are more business minded in terms of the world of weight and balance, this is not necessarily, don't worry if you're not following it exactly. It's we don't want to scare you away here, but it's a super technical area, which is more aimed at the developers in the background that would perhaps do developments to automate this process. So I'll pass over to Carol.
Thank you, Tom. Well, as Tom said, this is the nitty-gritty stuff of the project. And as a business person or a weights engineer or a DCS responsible, you don't really have to know the background of the or the structure of the X565. Yeah, I can compare it. If you operate your television with a remote control, you don't really want to know how that signal goes from the remote control to the television. You just want it to work, and that's the same thing here. So this part here is especially for IT personnel and developers. And as Trevor and Todd indicated already, the weight and balance manual contains a lot of data. And hence the data structure is also complicated. And since I was there since the beginning, the same as Tom, we already have developed an export from our weight and balance system into the X565. And we noticed that even if you're involved right from the beginning, it is a complex thing to develop. Hence, we decided to develop a comprehensive implementation guide to show and to help the future developers of how to develop such a thing. If we take an example, so you see there that we have a route. Under that route, we have a name, we have aircraft data, and so on. But if we drill down a little bit, next, please. Yeah, if we look at the hold configuration, and we're looking specifically at hold 3, yeah, from 31 left, from the positions 31 left to 41 left. Then we first of all see the information about the hold itself, yeah, which is the bay grouping, as the XML calls it. So we see where it starts, where it ends, eventually what the maximum capacity is, or the maximum weight. And from there on, we are going to drill down into the ULD positions. Yeah, so we see that 31 left, you can put an AKE in there, yeah? And this is only an example, because we would have a list of ULD types that are included or that can be loaded on that position. Furthermore, we have the maximum weight, 1,587 kilograms. We have the balance arms, and so on and so on. So every little detail that you will find in your weight and balance manual, it will be included in this XML file. To have another example, which is more of a pseudo XML representation, is that you see the structure here, and the structure of the XML is really following the physical structure of an aircraft. You see that we start at the level of the deck. Underneath the deck, we have holes. Underneath the holes, we have compartments, and underneath the compartments, we have ULD positions or load positions. And you see an example of all these details. And I can tell you that if you export, let's say, a 777, that we have over 72,000 lines of definitions in there. So that is quite a lot. But as a user, yeah, you will never see this complicated and non-human readable information. In fact, we want to keep the users as far away as possible from this technical way of reporting or communicating things. Now, because we want to take or get the user or the end user far away of it, or as far as possible away from the technical stuff, we have developed a front end. And for that front end, I'm going to hand over back to Tom.
Thanks, Carol. So, yeah, I think it's let's move away from the technical aspect now, move back into the kind of real world. Apologies to Carol for that. It's moving back into a proper visualization, if you like, of the data from the front end. So if we think about this data file, if we were just to open it up and look at it, it's not really designed as a human readable file. It's designed very much for computers to be able to take the content of it and do something clever with it. As owners of this data, we want to be able to see the data. So we still need to be able to visualize what's in there. We need to be able to modify elements of that data and just generally use it. So we have developed a kind of a front end to present the data to an owner of the file in a way that it is human readable and it's easy to follow and to manage and update and so on. So we've developed this Excel spreadsheet for editing the data, which will be available to everybody on the IATA website. You'll be able to just download this editor and manage files within it. So the idea is that we've got a button on the spreadsheet that you can press that will give you the option to open one of these data files. So you will select the data file that you wish to open, and the Microsoft Excel will just populate this spreadsheet with all of the content of that data file in a very logical kind of layout, so you can see exactly what you've got. So within the Excel spreadsheet, there are many individual worksheets that will be created by this front-end application for each of the different areas of data that exists in the specific data file. So here we can see, for example, in this tab, there's a worksheet for central gravity limits and so on. Now, in the other areas, we've put a lot of tools and kind of utilities, if you like, to help modify and utilize and view the data. So on this particular one, we're looking at the cargo hold data. So a lot of tables of information about individual cargo bays, cargo compartments, where the hold doors are located, and all of this kind of information. And the menu bar along the top, we've built some utilities there that allow you to kind of even get to a better view of the data itself. So in this case, the button draw hold, when you press that button, you will see this diagram, the cargo hold, with all of the data all laid out in a very graphical format, so that you can visualize exactly what you've got in a very usable way. So the design of this data file editor is to make your data management as easy and as simple as possible, and to help you in the management and modification of the data within the file itself. So in this example, just further down in the hold data, you can select on a particular bay position, for example, and it will highlight all the information about that bay in this very dynamic diagram. It will show you all the locks that are associated with that bay and so on. So there are many tools that you can use in this application to really help you with your data management. In this case, we're looking at the cabin configuration data, so passenger accommodation and so on. And again, we could just plot everything out on nice, easy to follow diagrams to assist you in the management of that data. Central gravity envelopes, again, a similar sort of thing. You can just press the button, see your data. So in the spreadsheet, you can change numbers, you can add extra numbers, you can delete whole records and so on. And then these tools will help you to visualize exactly what you've got in your data file. And also a kind of configuration table. So this is a summary that gives you a complete breakdown of all of the data tables within the file, all of the registrations that exist also in that file, and a matrix or a mapping to show you which data files or which data tables apply to which individual registrations. So don't worry too much about all of the technical detail of this. We will go through more detailed presentations. We will schedule further webinars to kind of walk you through exactly how to use all of this this information. So it could be possible, for example, that you've received a data file perhaps from Boeing or Airbus, and you want to add some of your own information to it. So using the editor, perhaps this kind of very airline-specific data, you can open the data file and push that information in quite straightforward. So we can see here, for example, on the sort of home page of this data file, if you press the menu button, navigate to pantry weight and index unit tables, you might want to then add some specific information. When you're happy with that, you can then go back to the menu and write the X565 data file, and it will take all of the information that you've been working on in your editor and create the new X565 data file for you. You can save that with whatever name you require. You can then send that information on to your DCS provider for importing into the database. So it's very easy to manage huge volumes of data. A lot of that information probably will never need to be touched. You can get that directly perhaps from your manufacturers. You add your airline data, import it into the database, and then moving on to the next step here, which is the validation process. So I'm going to hand back to Carol to talk about what happens next after we've imported the data into a DCS database. Of course, just like today, we still have a requirement to do validation. So over to you, Carol, to talk about validation.
Thank you, Tom. One has to realize that the X565 is nothing more than a text file. Yeah, it is an intelligent text file, but nevertheless, it is just text, which means that everybody can go into that file who has access to it and play around with it. Yeah, it is not advisable and it should be prohibited, but it is a possibility. On the other hand, once we have the data in our DCS system, yeah, configurators can go into your DCS system if they have access, and also there they can change things. So once in a while, we want to compare, and that is only one aspect of the validation. But at one point, we want to validate and check of what we have in our DCS system is really still the same as what we initially imported in it. So the way of doing this is in your DCS system, you are going to export the data into an X565. You still have your original 565 or X565 somewhere, and you can now compare the two files and identify if there are any differences. If there is no difference, then your comparison will tell you that it is okay. And so you can easily continue with using this data. If it is not okay, then an alarm will go off, and you will know that there is something going on and that you need to take some action. That is one use of the comparison tool or the validation tool. Another use is, and I see this almost every day. Yeah, an airline is sending us a new version of a 565, and in the joining mail they say, well, we have changed the dry operating or the basic operating weight of an aircraft. Now, if you trust, or if you put your trust in this email, you eventually going to run into problems because you don't know if anything else changed. Yeah. So what we need to do today is that we have to go through the manual chapter by chapter to see if there are any other differences in the file. With this new technology, this will be a problem of the past, because we can export the data that we already have in our system, export it, and compare it with the new X565 that we just received from the airline. Compare both of them, and we will straight away see what happened. or what changed. And if the changes make sense, we can then take the decision to import them in our DCS system or not. Yeah, if we decide not to do it, yeah, we can go back to the airline and ask them, yeah, are you sure that this is what you want? So it's all about making sure that the data that we have in our DCS system is accurate and that we know what is going on, yeah, which is a very, very lengthy process today. Something else that we want to do is to have or built in logical validations. Simple example, if you have a fuel curve, then usually your fuel curve is going to follow a smooth curve. Yeah, if we can represent the data as Tom demonstrated in the tool, and we can look at the fuel curve, we will straight away see if there is a spike somewhere, which probably will indicate a data issue. And there are many, many more logical validations we can do. For example, if you define a loading position and there are no allowed ULDs attached to it, then you know that position might be there, but it cannot be used because none of the ULD types are allowed. So it's along these lines that we are thinking to improve the validation process. And for the other stuff that we are planning and are playing around with in our heads, I'm going to hand over to Massimo to talk about future plans.
Thank you so much, Carol. In the meantime, if you and Tom also can have a look at the question and answers, both the one I have responded, both that I didn't responded yet. There's a lot of interesting questions, some of them technical, some a bit less technical. So we will address, of course, all your questions at the end of the session. So what we are planning for the future. Now we have the schema, the implementation guideline, primarily for developers and DCS providers. We have the editor that is in support of the airline to read and understand the data. But what are all the benefits about it? First benefit about it, we might have, as an example here, two different operators in the same airline group using different data. So if we are able to create here a service, a platform within IATA, we can easily then transfer the information from an operator A to an operator B, which eventually may use the aircraft with a slightly different limitation. So this is the case of airline groups. And this is one of the greatest benefits of implementing one single standard that we can to use and swap the limitation according to the type of operator we use. If we have electronic flight bag operated by our captain fleet that need to be updated in terms of basic weight, basic index, or pantry that has been changed, this can be pushed automatically, safely, securely in one push. So looking into the other use cases, inoperative locks for us airline, it has always been a pain, especially when you are in operation. If you get that one inoperative lock that has been discovered during the operation, it's always very difficult for a load controller to figure it out, which lock it is, what is the limitation. Sometimes you need to compare 4 or 5 spreadsheets to understand what is the real limitation. At the end, in operation, we don't have time. What we do, we leave cargo behind or bag behind. What is can be done here, if we can start to think about not only the aircraft semi-permanent data, but also the dynamic data that can change with MEL. If I have an inoperative lock, I can push the information while identifying the lock into the system, push it through the DCS systems that are using my line, and I can communicate that, you can now, for this aircraft tail number, I have an inoperative lock, and this string, this position is limited to 2,000 kilos as opposed to 4,600. When the lock is repaired, you can remove, bring it back to limitation as it was, and then reinform all the DCS system or systems that are handling your aircraft, your airline. Looking into other use cases, simple process of aircraft reweighing, other after maintenance processes that require a reweighing of the aircraft or regular weighing of the aircraft. Usually you have to produce a weighing report, then you have to send this weighing report centrally, then you start to change your database, and then you have to inform all the rest of the DCS providers around the globe to understand, just for a basic weight and basic index, this information can be directly inputted by the aircraft weighing engineer into the system, straightforward with a login, and then all the push is given in the real time to all the database that can take the new data and import in the system. Other use case that we can talk about is we know we are also an unpredictable business in ground, so we might need to let's say operate in short notice a charter of flights. Eventually, maybe there's difficulties in operating load control or weight and balance services at the station. They maybe use only one DCS. So what to do? It takes a lot of time. Sometimes you have to send the load master away. So if we can use the same file and can be imported by all DCS system easily, you will just have to produce maybe 1 or 2 tests of load sheet to ensure that the DCS is approved by the airline. But all the data are not need to be configured because they're all contained into that file. And if the DCS provider is 565 compatible, you will be able to import straightforward all your informations. Of course, there's also other business opportunities. When we look into the DCS outage, especially for those who have a big hub, it may happen one time every few years that you got an outage. And what happened? You have all your flights are delayed. And if you can push the information to alternative server with another DCS, you can recap your operation in real time, at least recover the crisis. Especially if you are in an hub, and you will avoid a lot of delay, which costs a lot of money to analyze. So moving on, looking into the overall here, cost and benefit. First thing first, we are reducing drastically the opportunities to have errors while inputting information and data. So safety first. But also if you look about here, the operational let's say, advantages that we do have, efficiency is a lot of money, and a lot of cases where we can see we have just displayed few of the opportunities for an airline, to use this standard format file and also push on their DCS provider to being able to use this system, to use the file, to being able to import the file. We have that flexibility to communicate safely data all around. Of course, we have also other type of benefits. So if we look at the perspective of the aircraft manufacturers, I wish to give to Todd and then Trevor their views on this particular project that we have done together. Over to you, Todd.
Yeah, thanks, Massimo. I think much of the benefit that I see has been reiterated a couple of times here, and the primary one I have is again flight safety. I see the X565 as a way to drastically reduce the errors introduced by manual manipulation of source data. And it can help our downstream users ensure that they consume the right weight and balance data. There's a source file that contains all that the correct data in the X565 format. There's certainly less opportunity for transcription errors or copy and paste errors, or just translating data from a PDF document to an electronic format, or just reading a paper form in and of itself. So again, I see reduction of potential data errors and using data as close to the source as possible as the real critical benefit for the X565. Trevor?
Okay, thanks, Todd. So from our perspective on the Airbus side, I'd echo your words and say the big driver from our point of view is going to be safety. In Airbus, we've had weight and balance manuals in XML format for several years now, and we did it really for our own benefits. It makes it easier for us to manage the data in there. The data, it's detailed, it's minute almost to the point of being invisible sometimes. So as you said, whenever you're pushing data, and as Carol said, if you've got to do validations afterwards, it's very, very difficult, and there are several entry points there for errors to arise. Personally, as a manufacturer, I don't think we're going to see that many efficiency savings on our side, but we see ourselves as being part of the chain. We're at the head of the chain, we're facilitating, and as Todd has said, in the longer term, where we're all going to gain is that of safety. So back to you then, Massimo.
So we have, of course, the DCS provider benefits. So starting with Karel and then over to Tom also.
Right. As a DCS provider that is specialized in freighters, I have additional issues or worries as opposed to a passenger airline or a passenger DCS provider. If we need to configure a freighter aircraft that comes straight out of the manufacturer's hull, then we have one document which is our Bible, and that is the one that we are going to use. However, if we are talking about a converted freighter, then we have two documents, and the manufacturers or the converters manual is going to overwrite or replace portions of the manufacturer's weight and balance manual. So it's a pretty complicated thing to compare the two manuals and see, well, what portion do I have to use now? So there is an analysis that needs to be done, and not everybody can do that. So you need specialized people that are expensive and that are going to take a lot of time to do this. Now, ultimately, if we would have the X565 from the manufacturer and we load it in, and then we take the X565 that the converter is providing us with two buttons or two actions, yeah, we have the correct configuration. Another big advantage for me is that everybody is talking about locks and missing locks or missing restraints rules. Of course, as an airline, you want to use the full capabilities of your aircraft. And if a lock is broken, you will say, well, now my maximum weight of that position is reduced, but you still want to use that position up to the max. The last time that in my organization we configured locks, somebody was busy for it for 3 or 4 weeks. And afterwards, we saw that as this person is also human, that there were errors in it. And there were plus misinterpretations of the rules that after 4 weeks we abandoned the idea and said, and that was around the time that we were starting with the X565. So it would be perfect to have this lock information and missing restraint rules straight from the manufacturer, so we can import it and implement it, and being sure that the information that we have is correct. Yeah? So that is for me the main benefit. So over to you, Tom.
Thanks, Karel. Yeah, for me, I'm managing a departure control system that is extremely complex and very powerful. It's very rich in functionality, but it is extremely data hungry. And it is a limitation because without that data, we just simply can't open up all the great functions that have been developed and provided to the airlines to use. So that is the biggest restriction. In this system, we have something in the region of 20,000 aircraft tail numbers. So 20,000 aircraft tail numbers, all configured to the highest possible specification, is a huge amount of data. And in the current manual processes using the old sort of data sheets and manual entry of the data, it's just not feasible. You really cannot do that. And always, again, coming back to that theme of flight safety, dealing with that volume of data, the risk of an error somewhere is much higher when you have a higher volume, of course. So from that point of view, the benefits are absolutely huge. Also, the ground handler point of view, so Massimo touched on this a little bit, the ground handling business. Very often, ground handlers they're working in an environment where they don't know what's coming next, and things happen at very short notice. So if a ground handler with very short notice has to perhaps handle a particular airline operating for a few days into a particular port, it could take more than a few days to manually configure that data. So the system is just not available. That data in the X565 format, if it is available and we can just import it directly into the system, we have instant availability of the system to use that departure control system. So the efficiency there for the business is really good. Also, again, another aspect of flight safety there, with good quality departure control systems where the machines are making the decisions, again, we have less pressure on the local staff at the airport or the low control staff doing things manually and potentially making errors because they're under pressure to achieve a specific timeline. So there are many different aspects of or benefits for very different areas of the industry. Also, from that point of view as well, the X565 data also includes everything to do with the cabin. So it's not just for a weight and balance or a load control system. We can configure check-in systems and so on with that information as well. So there are many kind of spin-offs that we can get from that. The aspect of validation is extremely important too, that Carol was talking about before. And I have a vision of, in the future, my strategy to use this electronic data is that every time potentially that we create a flight in a departure control system, is that we can do a cross-reference back to the source data to ensure that, in fact, the configuration that we have is absolutely correct. So if we've got an independent kind of record and we can always go back to that one, it doesn't matter what's happened within the departure control system. If somebody's updated something erroneously, then we can go back to that sort of master reference and make sure that everything is kind of squared away safely and correctly. So a lot of benefits there. In the end, as we said at the beginning, it really comes down to a huge improvement on flight safety, but also a great benefit in terms of time saving and cost saving for the airlines in getting departure control systems ready for live operational use. So I hand back to Massimo on that point.
Thank you. So we are coming to the conclusion that we'll go to question and answers. A couple of more slides. We have what we stand today. So Lufthansa Group is looking into the implementation of our 565, and they will ask in the next aircraft orders the manufacturers to deliver not only the weight and balance manual, but also the file of X565 format, so that they will be able to import directly and start to do the work without all the pain of transferring the data in the process that Tom has described. Some more good news. If we move to the next slide, the Pegasus airline has completed the implementation. They use our tools, our X565 editor. They have put together all their fleet of Airbus 320-214, and essentially they are completed the implementation. They run a test with Tom, as they are customers of Tom, and actually it did work. It's not yet live in operation. There's still some more work that Tom and Pegasus are doing to fine-tuning this, but at the first test, all the data perfectly went to the Altea database and are up and running. As I had mentioned at the beginning of the webinar, in the chat box, I have typed the link to download our implementation toolkit, which consists of 4 documents: the XML file 565, the implementation guideline for primarily DCS provider or system providers to use the X565 and make their software compatible to import and export the file. This is the job that already Karel and Tom have done in their own system and now perfectly can exchange between themselves files. We have the editor. Is an Excel-based program that can create, maintain, and also display all the data of the X565. It can also produce an X565 format. This is primarily for the line, but also other DCS provider can use to have an immediate overview of the data once they export the data, if there's any gross errors, and the user guide. All those are free tools that can be implemented. We are planning for the second part of the year also to do some more detailed, eventually information session on how to use those tools, which will be way more technical, perhaps one for providers of software and the other one for online that wish to use that. Now, I think we have a very beefy here question and answer box. So I have answered some already, but some of them are very technical. So I will leave, I mean, to all our team to respond with this. So one is, hi, would be is Nursel Erkan, which is working for Hitit, which is another DCS provider. Would be possible to add internal codes for this XML file if our weight and balance system need additional data which is not included in this file? Tom and Karel, that is for you.
Carol,
I don't even see that question. Where is it?
It's in the answered, because I just
in the answered. Okay,
alone, Nursel, I will let Karel and Tom to respond, but then I stopped to answer this because we have. So it's in the part of answered. So this is question number 2. Will be possible to add internal codes for this XML file. Now, our weight and balance system needs additional data which is not included in this file.
The answer is yes. In the XML structure, we have provided everywhere where there is a remark, you can include an XML tag or XML possibility that is called the any tag. Yeah, in that any tag, you can store whatever information that your system would need to transfer it between environments, for example. Yeah, I am using this possibility also. The only thing that we have to be careful of, and that is then more a warning, let's say, or a remark to Tom, since Tom made produced the Excel tool, is that we have to make sure that if there are any tags in the inbound, or let's say in the file that you read, that we would have to keep those if we write a new file. But basically, the answer is yes.
There was one question by Guillermo Toledo, which I answered. If the 565 must be certified by the states of operators, since somehow 565 will change the data management on the line side, it doesn't change the responsibility of the airline, which is the primarily responsible to produce the data. I'm not sure if you mean if today you are asking for approval of your weight and balance data to the operator, to the state. In this case, we can have a conversation offline, Daniel, if this is the case, and we can maybe involve your, let's say, state to understand how we work in these particular matters and what is the process internally. This is the same, for example, of certain type of matters which need the approval of the Civil Aviation Authority. I'm not sure if this is the case, but in terms of IATA and FAA, there are very clear regulation on the responsibility of the airline, which in certain cases does not require the rubber stamping of the data. There's one thing is that will the tool be owned by IATA or will be sold and over to manufacturers to their own XML files? We don't sell the tools, the XML implementation guidelines. All our tools are free for use for the entire industry. The question is if the manufacturer will charge for this. That is a question for Todd and Trevor to respond. If they were thinking of that the file would be charged separately. But I think that in the price of an aircraft, it looks to me a bit that the weight and balance data packages look about, I mean, a drop in the ocean, but please go ahead, guys. I mean, that was for you.
I'll say from our side, it's in this exercise so far, we've been looking at the technical capability. We haven't really talked about the commercial aspects yet, and that's really going to be a commercial decision. if you want it pushed, it's going to, the manufacturers are going to need to be pushed from the customer side. And in one of the slides, I think the Lufthansa slide, you mentioned that Lufthansa are going to be asking for data in X565 format in the future. So I think it's going to be a bit of market forces, really.
So the second question from Guillermo was, would whether 565 compatible with all different DCS used by the airline? This is exactly the aim for us, Guillermo, as an airline industry, and for me, especially as an airline association, to enable my customer airline to be able to communicate the data in case they have so-called station load control, and this may be handled by multiple DCS systems. So this is exactly why we are placing this type of project together, as this is exactly what we want to achieve, that all the DCS provider will be able to handle the data in this format. Question for Trevor and Todd. What are the plans for the manufacturers, where they stand today in the implementation of the 565 in this respect? So are they ready to produce the data? I think not yet, but I will let, they're working on it. So I will let Trevor and Todd to explain where they stand at the moment.
Well, from our side, we don't produce, as a matter of course, all of the weight and balance manuals in the format, but we've shown as part of this project that it can be extracted, and the extraction process was probably one of the easier parts of it.
Yeah, so much like Trevor mentioned earlier, we have the ability to produce XML weight and balance data. We have not explored the translation of that into the schema that has been developed here in producing a AHM 565 directly from that. So that's something that we're going to be working on or exploring in the future. Obviously, using the editor that Tom created would be maybe one possibility for us to explore about how to get our data into that format, and then publishing the XML 565 using that tool. So we still have some work to do to explore that.
Can I just jump in as well with this? One of the really big benefits of this concept of having an electronic data file is the flexibility that it will give us in the future to do all sorts of useful things. We're really looking very much in this presentation in the configuration purely of or entering of data into a departure control system database. And that data may be a small data set that we are familiar with in perhaps an old AHM 560 type format, or it could be a complete all singing, all dancing manufacturer's weight and balance manual with everything to do with missing and operative locks and MEL items and all of the other kind of very specific things. But in the end, it's just a platform for moving data from one place to another and being able to utilize it in very useful ways, configuration of the data, validation, all sorts of things. So, you know, I think it's by establishing this process and implementing it into the industry opens up a lot of opportunities in the future. And getting the data from the manufacturers is just one of those opportunities for us.
Yeah, and Tom, just to maybe reiterate that getting the data from us will not necessarily result in a complete XML 565. There's going to be data from the airline that's going to be required about the catering, the passenger weights, all those kind of things that we may not have.
Yeah, yeah, and the idea is that we will implement it in such a way with Massimo's kind of leadership, I guess, with this. In a way that it will be usable and easy for everybody to do. And that's really what we're striving for here. So please don't be intimidated by all this kind of technical talk and so on. We're really building a platform here to make life nice and easy.
Yeah, they were talking about validation a bit more. Yeah, there was this, or there is this question from Laverne. Hi, Laverne. In validation, at some point, or every DCS provider, well, we have to decide where the validation can take place. Yeah, you can validate logical things by only looking at the XML file, but other validations will have to be done by the consumer of the data. meaning by the weight and balance or by the DCS system that reads the data. Yeah, and so the question, are we going to be able to identify overlaps in positions by looking at the balance arms? The answer is yes, but we need to analyze this a little more to see, can we include this in the logical validations that we are planning to do, or is that a consumer decision? Or is it the consumer of the data that needs to do this check?
It's a very good point too, Carol, because having the data available means that anyone, an airline, a DCS provider, a manufacturer, whoever, can develop their own tools as well to do very specific things that they wish to do. So this is it's very much an enabler for open thinking and new opportunities.
Yeah, because there was an interesting in the answered section. There was a question from Sam Zoe or Soji. If I misread your name, I'm very sorry. Yeah, but we're asking, we as a weight and balance software provider, how can we use this infrastructure and service? Well, it is exactly what we provide is an infrastructure. It is a method of standardizing the data between airline manufacturer, DCS provider. So basically, as a weight and balance software provider or developer, you will have to change your system or extend your system so that you can export and import aircraft data in this X565 format. So there is quite some work to do as a software provider, but you will benefit from it greatly in the future.
Few more technical questions. Now we are moving to the open question, folks, so you can also read my speakers. So start from the top. Nursel Erkan, what about group ID loading methods of Boeing aircraft? This is very technical, so perhaps Karel and Tom can respond.
I think that if with group ID, this person is meaning the string loading or the bay grouping, then the answer is definitely yes, that is included.
Okay, Nursel, you know me, you know my email. We have exchanged various things. So if there's any particular technical question, put it all together. We'll respond offline. Fatih Atasoy, if EASA and FAA release generally strive for airlines CAM organizations, if so, would this project be supported by the manufacturers? I have to be honest, I don't get the question right. So there is a regulation about weight and balance in both FAA and EASA recommendations. And of course, our project is supported by the manufacturers because they're speaking here, but I might not have understood correctly your question. So I don't know if anybody else has a different opinion, but perhaps we can explain offline, Fatih, in this particular question.
Well,
move to the next is Bowman Laver. I think is the one you responded, Karel. Can you confirm
yes,
overlaps in position? So, okay.
Yep.
Any kind of assistant to airline room your side at the time to submit the request for approval that it states? Guillermo, we can talk offline this. If you explain your process to submit your data to your civil aviation authority, how does it work? And I will be happy to support it. There's a moving forward from anonymous attendee, a more technical question. XML is pretty rigid format. Is this X565 related to a fixed schema? And more other details. Can you give?
Yeah, if I can take that that away. At some point, well, we were all of us in the group here. We were involved. Most of us since the beginning in the creation of the AHM 565. At the moment that we started with the project of the X565, we had to freeze all changes to the AHM 565. Otherwise, we would be trying to hit a moving target. So now that the schema is there and it is alive and kicking, the next step is now to look at new requirements for the AHM 565 or in general for aircraft data, sorry, and extend the X565 as we go along. Yeah, this is a living thing. Yeah, as our we are moving forward, or the business is moving forward. The aircraft manufacturers are moving forward and introducing new possibilities, and obviously the X565 will have to follow.
I want to add that we want to reach a critical mass of the industry implementing the schema as is, which is already extremely good as is. It can handle all the aircraft type, and then we'll keep room for improvement, and then we will release an edition 2 with all the nuances or new data will be coming into the next phase. There's another question. If I understand correctly, manufacturers will issue 565 files. However, to my understanding, if these data files can be quite different after conversion from packs to cargo. Yes, Carella responded this is already. If you have a reconversion of the cabin to full cargo, it will be done by a converter. So you will have to remove a section of the file and overwrite it with the new bay grouping and the new configuration, of course.
Yeah.
Gerald, you
Now,
want
what
to
I
give
am,
a little bit more on this?
yeah, and what I am hoping, as a last remark, what I'm really hoping is that we get the converters on board, and that they will be able in the future to provide this conversion into an X565 instead of a paper manual or a PDF manual.
Following question is by
Also, just on
Right.
that point as well, that could be an external vendor that is developing a new passenger cabin for a cabin reconfiguration program for an airline. And it's quite feasible to expect there that the data that we currently see on a LOPA diagram, for example, being exported as a component of the X565 file as well. So there's no requirement there for somebody to be picking off balance arms and so on and revising an old AHM document for a new cabin configuration. That is quite feasible to come from the developers of the new cabin layout.
And just to be clear, at least from the Boeing side, we aren't at the point of releasing X565 data files. We do have weight and balance data for some of our models that is produced in XML language, but we don't have a translator yet. And we're working on exploring the tool that Tom has created to potentially create those files.
Yeah, identical from our side, yes.
Another question from Nursel is the aim completely removing 565. Why again 565 in Excel format being used? Well, I can start to respond this. The overall idea for the future for us as IATA is to eventually deliver a platform that can have an interface that is not in an Excel. However, it will take a bit of time to develop this. And the difference is that this Excel is an engineered one, can create after you put the data on an XML file and can read an XML file is quite different. And I will let Tom to elaborate a little bit more on this.
Yeah, as I said in the presentation, the Excel file there is just the front end of a data file, if you like, to help you create your data and view it and modify it. The data on the back end, the data file, the X565 file, is useful in this case because we can do interesting things with it, like import it in directly into a DCS database. We can't import an Excel spreadsheet into a DCS database directly. We can't export an old PDF AHM 560 into a DCS database. But the data file that the Excel spreadsheet kind of generates, you can do that with, and that's really at the moment the Excel spreadsheet concept is just a tool there to help you manage your X565 file for now. And hopefully, as Massimo was saying, the evolution of this takes us to way better things than that.
Yeah. Now, if I can add, the Excel AHM 565, or the goal of that Excel was to be a reflection, a one-to-one reflection of the paper 565, and put that into a more modern tool as in an Excel format. The basis of the new GUI that Tom developed Yeah, the basis is completely different. And you will see if you would compare the 565 XL with the new tool, that the formatting and the structure is a little bit different. Because it is driven by in a high to a high degree, it is driven by the format of the X565. That's why we decided not to continue with the AHM 565 XL, but start new, because we don't want to be limited by something that was decided 20 years ago.
Yeah, exactly. We kind of designed this editor to be as useful and as simple as possible, to be honest, so that people will want to use it, and it's not a burden for you to kind of transition towards it. And hopefully there's enough in it that you'll be able to look at, and you'll be very happy to be able to manage your data, add information and modify information through it. We'll talk more about that in the future, and we'll do some sessions, as Massimo said.
Yeah, we are running a bit late. We have already 15 minutes ahead, so I'll try to wrap up and trying to respond the last question. So one is, this data files can also be used by crew and maintenance engineer and manage deferred defects. Yes, this is the aim for the future. The one I was kind of displaying before, that if you want to load eventually using this data source through a service, all the MEL that are have an influence on weight and balance limitation, this is the future, and this is exactly one of the biggest benefits I see for the second phase. What we need now is to bring everybody on board.
Remember that expression, it's an enabler. It allows us to do all sorts of things that we could not do in the past.
Does ICAO or National Regulation Authority validate, monitor the transition of this new approach? Is there a need to involve regulatory authorities for regulating the change management process? This is a very valid question, and is a very complex one. We do have a very thorough regulations, both in EASA and FAA. I just named these two because they're the one I am more accustomed to. Definitely, it is going to be our role to involve them, to let them understand how we are digitalizing this process. It won't be a regulation. I mean, we are not, as IATA, in charge of any regulation, but we'll make them aware of this as an acceptable means of conformance to handle the data from an airline perspective, that we kind of show how the process works and how, and all the safety barrier that we have, the Swiss cheese that we are putting forward to prevent what happened and was already documented in the safety bulletin on FAA, the one I have displayed in the first place. Moving on, what is the link for downloading all this data? Can find a chat box. I reposted. If you cannot find it, I will send to everybody anyway. So but if you go in IATA.org ground operation, you will find it. So I hope you can see, Sam, how manufacturer will encourage airline to keep up on their weight and balance manual.
Well, I would say we won't. Just in the same way as today, we don't encourage you to update your ground ops manual. That's really between you and your regulator. But on the other hand, if it's going to be easier in the future, then it's going to facilitate the process for you.
So I think, if I don't know, Tom, if we have the last slide. If not, I just remind everybody that for any other questions or things that you want to ask us, always you can write to groundops@iata.org. And we will respond to you if you want to engage with us, with the team here. Okay, again, groundops@iata.org. For the time being, I wish to thank all these participants and for the incredible number of questions and interest that you have shown. And also I want to thank my speakers. This is our last webinar. The webinar is recorded, will be made available to all attendees, and we will upload it in our website. I will manage to communicate with all the registration people or where the tools are, and where you can access the webinar eventually if you want to see it again within your company. Thank you all from our end, and have a good continuation of the day.
Thank you.
Thank you.
Yeah, bye.
Thanks a lot. Thank you.